Hello, everyone. My name is Laura Schrake. I am the Senior Program Director for Business and Sustainability with the Council of the Great Lakes Region. And it's a pleasure to welcome you to our monthly webinar series, which is part of our Business Sustainability Network development, which is supported by the Fred A. and Barbara M. Erb Family Foundation. So thank you for joining us. Today's webinar is looking at industrial sustainability and the linkage that exists between water and energy, an important nexus as many industries target net zero in their operations. So during the hour we have today, we will explore the role smart technology plays in meeting water and energy saving goals. To lead us in the discussion are two very knowledgeable individuals in this field, both from Grundfos, the world's largest pump manufacturer. We can look forward to their presentation, which will also include a case study from the Great Lakes region. So the Great Lakes region, it's the economic region. It's an important region to North America for many reasons. It is comprised of 8 U.S. states, 2 Canadian provinces, and many First Nations, and home to 107 million people. If the region were a country, it would be the 12th largest country in the world by population. And at the center of the region are the Great Lakes, a significant freshwater system that holds roughly 20% of Earth's surface freshwater and 84% of North America's. The 5 Great Lakes have an important role in the well-being of the region's millions of residents as they provide drinking water for over 40 million people, and they sustain life for thousands of species. Additionally, the region is the economic engine of North America. Based on the region's economic output, again, if the region was a country, it would be the 3rd largest national economy in the world. The region's industries generate business that provide roughly 51 million jobs, and that is equivalent to around a third of the US and Canada's workforce. So the environmental value and the economic strength of the binational region positions it to really lead cross-sector and cross-border sustainability solutions that not only benefit and support North America, but also the rest of the world. The Council of the Great Lakes region is committed to facilitating those solutions for the Great Lakes region. We like to say we are solving for sustainability, and we work across borders and across sectors to convene on diverse perspectives, connect on issues that are critical to sustainability solutions, driving solutions to region-wide challenges. So some of our focus areas include circular economy, where we are working to forge a future without waste in the Great Lakes, starting with plastic waste. Water stewardship, where we are deepening information exchange on corporate water stewardship best practices. And decarbonization, where we are collaborating to create measurable, long-term impact in reducing emissions in the region. And together with our partners, we are cultivating a regional voice on these important issues. If you are interested in getting involved in any of these topic areas, please reach out to me or any one of us on the team at the Council of the Great Lakes region. We would be very happy to share more information and get you engaged. And in addition to our programming and webinar series, and as part of our role convening on key issues, the Council of the Great Lakes region annually hosts its flagship in-person event, the Great Lakes Sustainable Growth Forum. It was formerly the Great Lakes Economic Forum. This year, the forum will take place June 25th to 27th in Toronto. The website is on the bottom of the screen, and we'll also put a link to it in the chat shortly. I hope many of you will be able to attend. We have an information-packed program lined up, and it's a really great event and a good opportunity to network and discuss many of the issues and the pressure points that we touch on through our programming and during our webinar series. And getting back to our webinar series, today's webinar is focused on a critical intersection of water, energy, and sustainability within industrial processes. We have two great speakers from Grundfos who will highlight how innovative strategies and technologies can help industry progress toward net zero emissions and sustainable resource management. Joining us are Courtney Tripp, Grundfos's Senior Strategy and Sustainability Manager, and Tyler Johnson, E-Products and Controls Technical Sales Manager at Grundfos. Courtney will kick us off, and she'll then hand it over to Tyler. Following their presentation, we'll open it up for some Q&A. So should you have any questions for the speakers, please type them into the Zoom Q&A. Before we get started, I do want to note that as a result of request for a more interactive webinar experience, we have opened the chat for attendees to have an opportunity to engage with one another, so please feel free to use the chat. I do ask, however, that questions for our speakers are entered into the Q&A box and not the chat. This just helps me keep track of the questions as they come in and manage the Q&A session. So with that, I look forward to your engagement, and I'm very pleased to now hand over to Courtney Tripp. Courtney, it's all yours.
Thank you, Laura, and thank you for that warm introduction and for having Tyler and I here today. And I am going to get my screen share going. And Tyler, since I can see you, can you just let me know that the screen share is working? Fantastic. Thank you. As Laura said, we're joining you from Grundfos, and I'd like to start by just sharing a little bit about Grundfos before getting into more about the water energy nexus and how water and energy are critical as we drive towards a more sustainable future. So as Laura shared, Grundfos is the world's largest water pump manufacturer. But one of the things I always like to share is that if you go to one of our offices, what you see on the wall isn't something specifically about pumps, but rather on our walls of our office, it says our purpose is to help solve the world's water and climate challenges and improve the lives of people. It's a very mission-driven company, and sustainability has always been in our DNA. At the same time, I think it's important to understand the scope of the company. In addition to pumps, we're also a manufacturer of drives and controls and complete solutions for moving and treating water. We work across 4 divisions, including water utility, domestic buildings, commercial buildings, and the industrial sector, where both Tyler and I work. And for Grundfos, industry is quite broad. It includes everything from food and beverage to mobility, pharmaceuticals, electronics, renewable energy, and data centers. And here in the States, we've had a presence for the past 50 years, including local manufacturing in Fresno, California, and in Houston, Texas. So I want to share a little bit about when we talk about sustainability at Grundfos, what does that mean from an environmental sustainability perspective? First, it means we are committed to the UN Sustainable Development Goals 6 and 13, clean water and sanitation, and climate action. You see that also embedded in our 4 pillars under which our sustainable actions are kind of formed. Climate action, decarbonizing the flow of water through more efficient, smarter water pump technology and water solutions. Water action, reducing our water footprint and enabling the more efficient use of water management. And water access, increasing the water access for those people that currently do not have clean water and sanitation. In fact, last year, Grundfos helped millions of people to gain that access, and we will work to do that. So again, this year through our partners and NGOs. And finally, as Laura mentioned, circularity and embedding circular principles, not only in the way we move and think about water and water reuse, but also circular business in the way that Grundfos does business, and embedding circular principles into the life of our products from design to use. So I think it's important to talk about how linked water and climate change are. Whether we're looking at droughts or flooding, too much or too little water, or the amount of energy and emissions required to move and deal with water, so many of the climate impacts are on the front of water, from unpredictable rainfall to shrinking ice sheets, rising sea levels, and as I mentioned, extreme floods and droughts. So many of these impacts come down to water, too much or too little of it, or perhaps water that is not usable in the ways that we need. We need to break this cycle by decarbonizing the flow of water, using and reusing water more efficiently, and building more resilient solutions for business and society. Grundfos is very committed to this, and in fact took what many of us consider our boldest step yet in November of 2022, when we became the first water solutions company with approved net zero targets through the Science Based Targets Initiative, committing not only to drive toward net zero by 2050, but making near-term commitments by 2030 to make 50% emissions reduction in our own operations and hit 25% emissions reduction across our entire value chain. And I'll share a little bit more with you about what that means to us as a company and what that means how we are interacting with our customers and society at large as we drive forward. But a little bit more about science-based targets and what this means. The Science-Based Targets Initiative works to standardize the emissions reporting methodology, and it is based on the 2015 Paris Climate Accords. What is interesting today versus even a year ago is just how much commitment, whether through the Science-Based Targets Initiative or other net zero targets, are growing. In fact, science-based targets now represents 34% of the global economy by market capitalization when you look at the companies that are taking action in some form and have committed to science-based targets. It also includes 42% of the S&P 500 companies, and the US market is the fastest growing market for companies making these commitments. So certainly we are not alone on this journey. And one of the things that this means is that we are positioned to understand the journey that companies are on. We understand that as we look at science-based targets and companies making this commitment, it's not just about scope 1 and scope 2, which look at companies' facilities and companies' vehicles under scope 1, and purchased electricity, steam, and heating and cooling in scope 2, but rather looking across that entire value chain, looking at the upstream impacts of scope 3 through how we acquire assets and purchasing, to how our goods are sold, used, and transported out into the market. And in fact, this is where a unique challenge comes in for a company like Grundfos. Because when we look at our scope 3 impacts, we find that 99% of Grundfos's CO2 impact is our sold product in use in the market, because we are manufacturing pumps that go out into the market and consume energy. So while it is critically important that we're addressing our scopes 1 and scopes 2 and how we as a company do business, the largest impact we can make is partnering with companies and end users to drive sustainable practices and sustainability through the way they move, treat, and deal with water. In other words, our sustainability journey is in our customers' sustainability journey. And this means that we are laser focused on solutions and innovations to drive this forward. And in a little bit, Tyler will share a little bit more with you about what that looks like and how we can be part of this movement. In essence, our Scope 3 focus can help industrial companies achieve their Scope 1 and 2 targets. We've seen these impacts especially in Scope 2 and the way that companies are able to reduce the energy required to move and deal with water. An industry must also look at increasing and improving water efficiently significantly to benefit both the planet and business. When we look at total global water withdrawals, over 22% of global water withdrawals are used for industrial purposes. And at the same time, just a fraction of that water is currently being reused. And yet, in water treatment, there are examples where water reuse of up to 80% with intelligent pumps and solutions. Water efficiency is the untapped potential in the green transition, where we can look at more circular ways to use this precious resource that is so critically important across every area of industry, whether we're looking at producing vehicles to producing the food and beverage to feed our growing planet. Industrial energy consumption, when we are specifically looking then at industry and industrial energy, also presents an opportunity. 38% of the global total energy use comes from the industrial sector. And pumps account for a large percentage of this. And the challenge that we face when looking at all of this is that it isn't just a matter of doing the same while requiring less energy and less water. But when we look at energy consumption to meet the growing demands of everything from advancing technology to a growing population, we see that energy consumption in industry is expected to grow by 35% by 2030. So the challenge before us as we talk about the journey to net zero and the journey to a more water sustainable world, we're looking at the challenge of doing more with less. And this is a challenge that I truly do believe that we can meet, and that there are technologies, most of the technologies needed to exist today to meet these very challenges. The other thing I want to highlight is the importance of energy efficiency. So often when we talk about sustainability, renewable energy and the shift, the energy transition is something that comes into direct focus. And yes, this is an important part of that transformation that we are on to build a more sustainable world, to look at ways that we can incorporate renewable energy and more sustainable energy generation. And it's also critically important that we don't forget to first look at the ways that we can become more efficient. And in fact, energy efficiency related action account for 1/3 of the emissions reductions required for net zero and the UN Sustainable Development Goals, which means we can get 1/3 of the way to where we need to be when looking at efficiency gains that can be made. And this is where we're highly focused on being part of that carbon emissions reduction through efficiency gains and smarter ways to do the jobs that we've been doing. So as Laura was introducing us, she mentioned this water energy nexus. I like to say that my world exists somewhere right in the center of that donut, right in the middle of this water and energy world. Water is critical for energy, and especially as we talk about this transition to greener developments of energy, water is critically important, whether we look at the production of green hydrogen or hydropower. It's also critically important to cooling, which is only growing in demand as we look at the growth of things like data centers. At the same time, whether we're looking at water transmission, water distribution, or wastewater treatment, energy is required at every juncture that we look at moving and treating water across every use, including that use within industry. So I want to share a few more facts about the ways that water and energy are so interdependent. By 2025, just around the corner, water scarcity is predicted to affect 66% of the global population. And as I talked about this power generation and this growth of green power generation, 90% of global power generation is water intensive. And in fact, when we look at what impact the water industry and the water sector can have when we talk about the journey towards net zero, 4% of global carbon emissions could be saved within this water sector. So as we look at smarter ways to deal with water, as we look at advancing water stewardship, advancing circularity, we're also looking at how we can be a part of the net zero transformation by the ways that we deal with water, the way we steward water, the way we treat and deliver water. And as I like to say, oftentimes untapped potential exists in pumping applications. Often when you talk to folks, there are things that are synonymous with the move towards more efficiency and better use of our energy and the decarbonization movement. Everything from renewable energy to LED light bulbs quickly come up in conversation. But what doesn't often happen is for companies and people to first think about pumps as this incredible area of opportunity where more efficiency can be built into operations, where more carbon can be reduced, because pumps account for 25% of all electricity consumed by industrial electric motors. So often in a back room or a basement or a place that may not have been thought about in a long time, there's a tremendous opportunity to increase efficiency and to advance the journey towards net zero by looking and thinking about pumping solutions. And as I get ready to hand it over to Tyler, I think it's important that we think about how these pumps and water treatment and movement solutions can be thought about not as a singular entity, no longer just as a pump, but as a pump with integrated motors and variable speed controls and/or complete package solutions, sometimes complete with digital connectivity as we move into Industry 4.0 and smarter ways to move, treat, and deliver water, advancing us not only towards better water stewardship, more circular ways to use water, but also towards a net zero future. So I'll hand it over to my colleague, Tyler, to tell you more.
Perfect. Thank you, Courtney. Yeah, so welcome everybody. So we're going to dive in my portion of this into a little more of the technical side and the why and how Grundfos does what we do. So we'll go ahead and jump to the next slide. So in Grundfos, one of the big things that we talk about and we promote is our smart pumping options. So whether that's a single pump system, anything from residential pressure boosting in your house to a multi-pump system for an entire industry or an entire factory. These systems all come with complete system control built into our motors and our control systems. Permanent magnet motor technology, which is good for 7 to 10% energy savings over a standard asynchronous motor. So not counting any of the driver control, just right off the bat, you have another 7 to 10% more energy saved with permanent magnet technology. Best part about these systems, they can be run completely standalone with built-in PID controllers, or we can integrate right into your PLC very seamlessly. We can do multi-pumps and cascade control, which we'll talk more about here in a couple slides. So our flagship product for Grundfos Industry is what we refer to as our CRE. This is a vertical multi-stage pump that the pump alone carries efficiencies up towards the 90% range. So very efficient pump design paired with the most efficient motor design on the market for multi-stage pumps. These are all permanent magnet, anywhere from half to 30 horsepower. They have a built-on integrated VFD with PID control in it. And these pumps fit a wide range of applications from a couple gallon a minute all the way out to over 1,000 gallon a minute. And we're utilizing these pumps and systems where we're building close to 600 PSI in different configurations. You can see we offer very wide working pressure and also temperature range too. So down below zero, all the way up to 248 degrees Fahrenheit. So boiler feed applications. That's a huge upgrade potential that we see for efficiency gains and helping our end users meet their sustainability goals, along with chilled water, condensers, HVAC, irrigation, and then just general house water feed. So next we look at not just one pump, we move into a system. So at Grundfos, we are a complete system provider. So we are a pump supplier, we're a pump manufacturer, but more than that, we like to look at everything as a system. And one of our best-selling products is our Hydro NPC. This is a one-stop shop full skid system with piping, valves, check valves, pumps, motors, drives, and controls. The best part about this system is our controls that we use. We have a proprietary algorithm built into these controls that actually looks at what your system is using. The controller has the pump curves built into it, so it knows the best efficiency point for the pumps that controller is paired with to run at. And over time, it starts to calibrate itself and change how many pumps run and at what speed they run to consume the least amount of electricity as possible. And a really cool part is we can actually display that on the home screen for our end users to follow and watch to see exactly how many kilowatts the pump system is consuming at any given time. These systems come from teeny tiny little 20, 30 gallon a minute, two pump systems, all the way up to multiple 1,000 gallon a minute, 6 pump systems, and all utilizing the exact same controller, very easily integrated into your PLC and super efficient. So next we will look at what's at the heart of these systems. So Grundfos, our MLE motor. This is a motor with integrated drive manufactured by Grundfos. These are all IE5 NEMA Ultra Premium efficiency. Your standard motor out on the market is an IE3 NEMA Premium. That's what you find on 90% of standard pumps anywhere in a factory. As I mentioned before, the permanent magnet, you're good for 7 to 10% energy savings. And we have an efficiency up to 97.5%. What that means is with the permanent magnets in there, we're not losing a lot of electricity to create the magnetic field to get the motor running. The magnets are already generating that field, so that allows us to have a quite high efficiency rating. They all come with a graphical interface, so you can program it right from the motor, or we also have a app that's available on Apple and Android to program these, pull reports from, get information from, very user-friendly. As I mentioned before, this has a built-in PID controller in it. So we have 7 pre-programmed functions. So whether you want to run constant pressure, constant temperature, constant flow rate, control level from a reservoir, however you want to do it, that functionality is built in from the factory, very easily programmed through our startup wizard. PLC integration, we can talk to, I would say, virtually any PLC out on the market. And included in that, we have alarms and warnings. So we can set different parameters if you want low pressure alarms, if you want alarms for over voltage. The pump has a lot of built-in safeties and protections for itself. And then also too, we can connect 4 of these motors paired with pumps in line without any extra controller, and they will run in cascade. What cascade is the ability of the controllers in the PID loop to decide how many pumps need to be on to achieve a set pressure through varied flow rates. So sometimes during the day, you may only need one pump to run. You have a crew comes in and does some cleanup. We can have all 4 pumps run. That makes these systems super efficient because we're only using the pumps that are required to meet the demand rather than assuming for worst case scenario. You can see on the right-hand side there, that's a little graph showing you the motor efficiencies. So everything in the white bars there is our Grundfos MLE efficiencies up into that IE5 range. The gray bars, that's your standard NEMA premium motor that you can purchase anywhere out on the market. So when we get above 30 horsepower, Grundfos also manufactures our own external variable frequency drive that we call the CUE drive. Shares a lot of the same functionality and features that the MLE motor has: graphical interface, pre-programmed functions. The biggest, I'd say, sales point or the best thing about this drive, it is designed for pumps. It has an easy to use startup wizard that walks you through and asks you what kind of Grundfos pump it's paired to. Once you enter that information and you say, I have installed this on a Grundfos CR, it pre-programs a lot of the back end. So this saves integrators and maintenance guys hours of programming versus a standard VFD out on the market that could be used for blowers or fans or pumps or whatever it might be. Our drives are designed and built specifically for pumps, which makes them very efficient in what they do. Again, PLC integration, alarm and warnings for system protection. We can supply these up to 700 horsepower. And then also come in a variety of installation classes. So they can be mounted inside down to NEMA 1, or we have NEMA 4X IP66 outdoor rated drives. So very versatile in the installation and very user-friendly. So whether it's the MLE or the CUE, you can see all of our systems that we provide and build have variable control. And we're going to kind of go into why we do that. So control matters. Intelligent motors and controls are great, but without a good control scheme or sensors out in the system, they will never meet their full potential. And then the next slide here, we're going to kind of hopefully give a little simpler explanation for everybody on that. So we're going to use the context of driving your car. So you got my beautiful picture here. This is representing if you came out and visited my home state of Colorado, you were driving up through the mountains. The top picture there, that is most pumps out on the market. When they are turned on in the morning, it would be just like getting in your car and putting the accelerator all the way to the floor, and then using the brake to speed up and slow down while never letting off the accelerator. Not a very efficient way to do it. I don't think I know of anybody that drives their car that way, but that's how we have pumps running out in the market right now. They're just sized for worst case scenario, and they are turned on and they just run at full speed all day long. Now, if we go down and look at why control matters and why we use variable frequency drives on most all of our systems, that would be like cruise control in your car. The motor is speeding up and slowing down depending on the need of the system. Think of the hills on my little picture there as your flow rate in your system. Sometimes it's higher, sometimes it's lower. The pump is able to slow down when it doesn't need to send so much water out to the system and pick back up when it needs to. This is where we gain energy efficiency. This is where we use tremendously less kilowatt hours per day or per year within a plant. We've had plants where we've gone in, checked the existing system, upgraded to the more efficient variable frequency drive with smart controls, and we've saved over the course of a year anywhere from 20 to 50 houses of power used. And that's based off of, in the United States, your average household consumes 10,500 kilowatt hours per year. I was just doing one this morning for a large end user, and they're going to save 384,000 kilowatts of energy over their existing pump for this exact reason that I just went through. So next slide. So when we look at our control modes, we have constant pressure. That is our most common one. Most industrial end users want to maintain a set pressure out in their system, whether that's for their boiler feed or for their wash down system, or even just sending house water out to supply faucets and bathrooms. You want to maintain a constant pressure. So the little graph on the right is just kind of an explanation of how that works. So we have our pump down there with the little blue circle with the triangle in it. And the pump is spinning. Pumps are, I always like to say, they're kind of a dumb piece of equipment. They're only doing what the motor is telling them to do. So we have the variable speed drive and the PID controller built onto the motor. That is taking in the signal from the pressure sensor, which is telling it how much pressure do I have in the system. It interprets whether it needs to speed up or slow down. That's where you get your efficiency from. We can also do this based on temperature, flow rate, differential temperature, differential pressure. And we can also do this based on level. So we can maintain levels in tanks, or whether that's filling or emptying. We also have what we call constant curve, which is the ability for the end user to set a speed or give a speed signal from a PLC to tell the pump where it needs to run at. So connectivity. Grundfos pumps and systems, we can take the place of a lot of costly PLC components by integrating a lot of that control into the motor. Whether that be flow meters, analog signal sensors, or chem feed pumps. Those can all be integrated directly back to the Grundfos motors or controllers. This saves a lot of expensive hardware and a lot of complex wiring and system configuration by doing it all in one package. So on the next slide here, we're going to kind of show you an example of that. So this would be like a reverse osmosis system. We have the ability to control a complete reverse osmosis system with one motor with our PID control that we have built into our MLEs. So we have, you can see there, a solenoid valve on the inlet. We have a pressure switch. We have a permeate and concentrate flow meter. We have a flush solenoid valve, differential pressure, and then we also have tank level in our permeate tank. We're able to take all of those inputs and outputs and bring them back into the motor and control the RO system as efficiently as possible. This is very helpful in an RO because by judging the differential pressure, we can flush the RO membrane when it's needed. Courtney had in one of her slides before how much water industrial reverse osmosis uses. It's a lot of energy, very energy intensive, and reverse osmosis by nature likes to waste a lot of water. If we can calibrate our flush cycles accordingly, we can save end users a tremendous amount of water and energy, where a standard reverse osmosis system is just flushing based on time. We're only going to do it when it's needed. So this is just one example of how we can integrate a lot of different controls and features into one motor without the need for a complex PLC and control box. So on our next slide here, this shows kind of how bought in we are to this technology. These are all the different products that Grundfos manufactures where we incorporate our MLE permanent motor technology, whether it's industrial, commercial buildings, municipal, residential, the list goes on and on. We incorporate this motor and all the control features into anything from a machining tool pump up to big skids for a complete factory, down to small circulator pumps for industrial and commercial buildings. And then we also incorporate this onto a end suction pump line that we manufacture, which I'll mention as well, has stellar efficiency ratings when paired with this motor technology. So you can see this is a flagship for us, and it's something that we put a lot of pride into. Grundfos ourselves, we reinvest 5% of our profits per year back into R&D. So we develop these motors, and we really put a lot of thought and a lot of time into how do we control these in the best way possible and make them as user-friendly for our end users as we can. So I believe next we're going to jump to a case story and kind of show you guys a how and where and give an end user's perspective on a scenario like this and these kind of products. So this case story, we utilized our Grundfos CR95s, which are quite large pumps. These pumps are capable of producing almost 500 gallon a minute each. And this was at a chemical plant. So the end user name is omitted, but we do just state that it is a chemical plant. And we used a Hydro MPC, which is our booster systems, with our CU352 controller, which is the brains behind the whole operation. So I think next we have a lovely little video to show you guys.
We're a chemical processing and distribution company, and we manufacture water treatment chemicals for the end user.
Grundfos Pumps handles 100% of our water needs. So they do our boiler feed water, they do our raw water demands, and they also do our potable water. The old pumps were Gorman Rupp, and they were very hard to maintain, very costly to maintain. They took a lot of time, materials, and money out of our pocket on a yearly basis, so it was time to make a change.
A lot of the challenges were reliability with their previous system. So there were a lot of service issues. They were continually having to shut their old pumps down in order to fix them. So the CR95 is part of our completely new hydraulic range for our vertical multi-stage pumps, which allow us to reach applications that we weren't previously able to do. Other applications including reverse osmosis, wash and clean, and temperature control.
They are low maintenance, almost maintenance free, very efficient, very quiet. Before we had a very noisy room where we had to use hearing protection. We eliminate that now. So that's another hazard removed from the area.
The 4-pump Hydro MPC system allows the customer to take one of the pumps down, service it, and the other 3 pumps are still able to handle their system demand. So they don't have to shut down the entire plant. They can keep operating and get that other pump fixed.
Already we're saving over 30 grand a year just on rebuild costs in the maintenance side. When we started doing the legwork on it, we already knew that IPE was going to be the go-to. So we got Dave Ross and his team out here to help us out.
IPE has been in business for the last 23 years, and we've been partnered with Grundfos since the beginning. Without the capability of the new Grundfos CR95, the customer's flow and pressure demands wouldn't have been possible in the past.
The pump, we set it and leave it, and it pretty much senses pressure and demand in the plant, and it'll ramp up and ramp down automatically.
So depending on how much demand is needed for the plant, the pumps can adapt to those changing environments. It actually calculates which will be more efficient, running 1 pump at 100% or running 2 pumps at 50 or even 40%.
We're really happy to be using the Grundfos product, and it's been very successful, and IPE is taking great care of us, and the service has been excellent.
Excellent. So that case story just kind of showed some of the highlights and benefits of our complete skid package systems. And we'll just kind of end with a quote from our founder, Paul Dudrenson. The world is full of problems that can be solved in a better way. I think that's how everybody that works at Grundfos, when we sit down at our computers or walk out in front of an end user, that's our mentality, is let's not just look at a singular pump. Let's look at the whole entire system and how do we do this in a better way. So with that, I think I'll kind of turn it back over to Courtney for a last word, and I think we'll get some Q&A.
Thank you, Tyler. And thank you again to Laura and to the Council of the Great Lakes region for having us on here today. I'll just put our thank you slide in case anyone wants to take down that contact information for any follow-up questions we might not get to. But it's really exciting to be able to share with you all just the possibilities that exist when looking at the ways we move, treat, and deal with water, with looking at new ways to think about entire systems versus isolated pieces or components, and the ways that we really can decarbonize the flow of water through efficiency and build in circularity to the way we use that water to address both net zero and build a more water secure future for the world. Thank you.
Great. Thank you, Courtney and Tyler, for your presentation. That was great and really interesting. I love that you touched on the systems approach to solving these challenges. I think that's really important. And Courtney, you threw up some numbers that really caught my attention, and I made a note of them. So I just kind of want to emphasize them because I think they're really eye-opening, but that greater than 22% of total global water withdrawals are used for industrial purposes. Less than 15% of total industrial water use is being reused. And 38% of the global total energy use comes from the industrial sector. So I just thought those were really eye-opening and great figures to share. And it really also highlights the potential impact that technology can have in industrial sustainability. So thank you for sharing those numbers also. I thought it was really, really great to just sort of have that awareness. But I want to go ahead and so we've got about 15 minutes. And so we'll start the Q&A. I'm going to go ahead and start with one from Carrie Ann that came in with the registration. And she states net zero typically refers to energy. And she asks, when will we start or need to aim towards net zero for water?
Yeah, that's a great question. And one of the things that we, didn't get into deeply in the conversation today is just kind of that difference when thinking and talking about water sustainability and emissions. And I think what it comes down to most is water is so local. When we look at whether it's the Ogallala Aquifer here in Kansas, Colorado River Basin, the challenges in places like Florida and California, or the state of the Great Lakes region, each one is facing unique challenges, sometimes with challenges around too much water or the wrong kind of salt water or not enough water. So applying that net zero framework is a bit challenging because that looks at water. Carbon is carbon. The same ton of carbon is the same ton of carbon no matter where it is in the world. Whereas with water, depending on that risk of the watershed and what needs to be addressed, it can be more complicated. I like to talk about a water secure future where we feel secure about the amount of water we have enough water to meet that need, but then also water is not a threat. Because I believe that's a bit more flexible to the different local needs that exist when we're looking at what a sustainable future for water does look like.
Yeah, that's great. And I think that's really helpful to put it into that context. It's not necessarily apple for apple when you're talking about carbon and water. So that water security is a great approach. So thank you for answering that question. A question that has come in live through the Q&A is from Riley, and he's asking how Grundfos achieves reductions in its upstream scope 3 emissions.
It's a great question. So, of course, that upstream scope 3 is going to include everything from fuel and energy related uses, transportation distribution, our suppliers, as well as purchase goods and services, etc. So and of course waste from operations. So without getting too deep into the weeds, we are actively working with all of our suppliers with targets for how those suppliers are going to be going through processes with, working with some of the climate rating agencies to get a scorecard look at where they can also become more sustainable so that we're procuring supplies from sustainable suppliers. Another big area is this whole area of waste from operations. And kind of, as I mentioned, embedding those circular principles into the ways that we are producing our goods. So looking at not only the, waste reduction, in terms of how we are, using packaging and transport and supply, but also looking at, do materials hold up so that we can grow things like take back programs and reuse materials from pumps that have already been in the market, and maybe that pump is no longer usable, but materials from it are usable. So there's a and then, of course, our business travel is being evaluated as another area where we have gains to be made. So there's a lot of focus, and I have several colleagues who are very, very focused on that supply chain and operations piece, who have roles specifically dedicated to that area of scope 3.
Great, thank you. Yeah, it's interesting. Obviously, you've got your own reductions that you're targeting within your operations, and also then looking at how you can support your customers and clients to also reduce their consumption and emissions. So you've got a couple different sort of directions that you need to go in when you're looking at reduction. So thanks for answering that. From your experience, what have you found to be the biggest challenge for industry in tackling excessive consumption and reducing their energy and water use?
Tyler, do you want to jump in on this one? Or would you like me to? I can also kick us off a little bit.
Yeah, I can take that one. When you just look at industry as a whole, it's a lot of old school thought process and way of going about things. And in the US, we have a lot of very old plants that require a significant amount of upgrades to even start to think about how do we reuse water or how do we do things more efficiently. So there is a big expense hurdle and just a logistical hurdle of we can't have the plant down, but we need to redo the whole thing to start getting it up. So it's a lot of strategic thinking on piece by piece. How do we walk through this plant and start upgrading things in an efficient manner without having the plant down? And I'd say that's probably one of our biggest hurdles with our end users.
Yeah, and the one thing I would add to that is, and something that I've been, have talked to end users about, is just this challenge of, some of these companies making these commitments are very, very large operations. The corporate C-suite has made this dedication to, okay, we're driving towards net zero. But taking that and then mapping what does that look like operationally, and then working down to the level so that that maintenance engineer understands the role that they have to play and the desire that that company has to hear their ideas and their understanding, because the C-suite may not even be able to tell you where the pumps are located, but that connecting of those dots and then that empowering of those frontline employees and those maintenance engineers and so forth to be able to contribute to these goals. I know there's a lot of companies focusing on that now and trying to figure out how do we build those bridges, build those ways to be able to address these challenges. But it has been an ongoing challenge in the past to connect those dots.
Sure, I can imagine. And are you seeing more progress or like more ambition in any particular industry?
I would say, what we've seen so far is that the food and beverage industry, I would say, is kind of a bit more of that front running industry. I attribute that to a few different things, but one of which is, of course, that, food and beverage is really close to the consumer. And as consumers become more mindful of how those, beverages or the food they're eating and snacks they're consuming are produced, that becomes a potential competitive advantage for that company to be able to, be able to speak to their water stewardship and their net zero ambitions and progress that they're making towards that. I think also when you look at things like, especially on the beverage production side, I'll never forget when I was touring the Guinness factory, they have a wall that says brewers are precious about their water. So I think there's also that appreciation of water that exists, particularly in the beverage industry, in a way that you might not see in other industries quite as much.
Mhm. Sure. And that makes sense. Riley has put in another question in the Q&A, and I want to jump to it. He acknowledges this may be a tough question for a pump company, but expanding on the point made regarding water stewardship, he's asking, are there any guiding principles from local indigenous communities being incorporated into your water stewardship strategy?
That's a really great question. And I probably can't fully answer that other than to really be appreciative of that input. And would we desire that input? Absolutely. We actually have some global work ongoing right now to revisit our water stewardship, to advance that, to take what we know now and strengthen some of those commitments. So would love to open that dialogue to continue a conversation about if there are, ways that we can learn it and incorporate that. We certainly would be open as a company. And certainly also as we look at some of that work that we do with, if there are, water insecure communities or communities that don't have clean, safe, sanitary access, that's something that we're, deeply dedicated to on an annual basis, investing both money, but also time and resources to building out that infrastructure for communities that need it.
That's great. Yeah, and I would also add just on from the Council of the Great Lakes region, we're using our platform to bring all stakeholder groups together so that all views are representative, and we certainly welcome Indigenous communities to the table across all of our programming and topic areas, especially water stewardship, but all of those topic areas, and it's certainly an important voice to have to the table. So thanks for answering that question, Courtney. We have just a couple of minutes left, so probably time for one more question. I'm going to ask about sort of the typical return on investment for implementing this smart technology that will offer water and energy savings. And I realize that it could, certainly vary based on the scale of which it's being implemented. But are there any examples that you could share, or just to give the audience a little bit of insight on that ROI?
Sure. So in the US, it's very interesting. ROI fluctuates quite a bit depending on your location. If you just look at cost per kilowatt hour for industrial plants in the Midwest or in the Great Lakes region, power is actually kind of cheap compared to other areas. You guys, I think everybody in that runs in about the 7 cents a kilowatt hour range. You go out to the East Coast, that can double up to 14 cents. You go up to Alaska to kind of touch on the indigenous stuff. They get up to the 20, 25 cents a kilowatt hour range. So ROI is, dependent very much on how much their operational costs are. And then it also depends on the current equipment installed. There are some older accepted technologies out there for, say, high pressure washdown, for instance, that carry very high maintenance costs in the tens of thousands up to $100,000 a year just in maintenance cost. So an example like that, you could have a payback time around 2 years. We've done other ones that might be 5, 6, 7 years for a payback time. So it is highly variable depending on age, location, what kind of system we're looking at. And I suppose, just to be blunt, how good or bad of a job they're doing right now at controlling their system that they have installed. So yeah, there's a lot of variability. I don't have a great answer for that one.
Yeah, sure. Thanks. Well, I sort of suspected that answer when I asked the question, but Thank you. And so we are at the hour, so that's all the time we have. Courtney, Tyler, thank you so much for your presentation and for the great work of Grundfos in helping industry drive greater efficiency. Also, thank you, audience, for joining us and contributing questions. We will have a post-webinar survey hit inboxes soon. If it could please be filled out by our audience, we'd appreciate the feedback. They help us improve our webinars and make sure that we're hitting topics that are important to all of you. And a recording of today's webinar will be available around this time next week. And lastly, I hope that everyone will register and join us in Toronto for the Great Lakes Sustainable Growth Forum in June. It'll be a great opportunity for this conversation and discussion face to face, which is always nice. And so again, Courtney and Tyler, thank you so much. It was really great to have you on our webinar series.